Okay, welcome back, guys. We're going to talk today, or we're going to continue on today about naming ionic compounds. If you remember last time, we did the crisscross method. We went from the name to the formula, and we also went from the formula to the name. We're going to build upon what we talked about last time. I've just given each of you a table that has some common polyatomic ions on it. And so this slide here contains some of those polyatomic ions. I wanted to go through and just kind of point out some of the ones that you should remember from first year chemistry, some of the more famous ones or well-known ones or common ones. Hydroxide, OH minus. Should remember that one. Nitrite and nitrate are pretty common. Let's see, some other ones that you might remember. We used a little bit last time. Sulfate, SO4 has a 2 minus charge. Let's see. Yeah, there's ammonium. We talked about ammonium quite a bit. Cyanide, CN minus. So there's a lot of ones that you probably remember, but I've given you a table in case you've forgotten some of them. We might use all of these, so it's a good idea to know what they are. Okay, today what we're going to do is learn how to name ionic compounds with polyatomic ions in them. So like it says on this slide, when the compound contains a polyatomic ion, you name the cation followed by the name of the polyatomic ion. So it's very easy. The cation, you're just going to look up on the periodic table, the metal, and name it. Whatever its name is, you just keep it the same. If there's a polyatomic ion in it, for the anion, you just look it up on the table and keep the name the same. Don't change the name. Let's go through some examples and I think it will make sense. Okay, practice problem number 9 says to name the following ionic compound, and it has a polyatomic ion in it. So first of all, let's go to 10. What's the polyatomic ion in this compound?
Hydroxide.
Yeah, it's OH, it's hydroxide. Okay, so there's our polyatomic ion. Now let's name it. Na, what is that, guys?
Sodium.
Sodium. So do we change the name at all?
No.
Just sodium. And the polyatomic ion, like Tanner just said, is hydroxide. So do we change its name? Nope, we just write it. You just look it up on the table and keep its name the same. Sodium hydroxide. Okay, so these are very easy. Practice problem number 10. Mg, what is that, guys?
Magnesium.
Magnesium. Never change the name of the first one. What's the polyatomic ion, though?
Sulfate.
Sulfate. Do I change its name? Nope. So even though it doesn't end in IDE, we don't change it. If it's a polyatomic ion, you just keep it the same. So that's magnesium sulfate. Very good. Practice problem number 11. Okay, this one's given us the name, and it wants us to write the formula. So, potassium permanganate. Let's remember back from last class period, what do we do if it has the name? What's the first step if it gives you the name and it wants us to come up with the formula? Put the charges above the name. So let's look up the charge of potassium. What is the charge of potassium? Plus 1. Okay. Now permanganate, you can look a long time on the periodic table. You're not going to find it. How come? It's a polyatomic ion. So we get that paper that I just gave you, that table, and let's look up permanganate's charge. What is it?
-1.
It's a -1. Good job. Now what do we do?
Crisscross.
Let's crisscross it. So that one comes there, this one comes over there. Do I ever bring the signs down? Nope, just the numbers, okay? So potassium, what's its symbol?
K.
K. So do I need to bring the 1 and write it right here? Nope, it's implied. Permanganate, how do I figure out its formula?
Look on your table.
Yeah, look on the table. Nice job, Ruben. So it would be what, Ruben?
MnO4.
Good. MnO4. Do I need to bring the 1 down? Nope, 1's implied. So there we go. Potassium permanganate. Very good. Let's do another one. Number 12, sodium phosphate. What's the charge of sodium, guys? +1. What's the charge of Okay, phosphate, again, not on the periodic table, must be a polyatomic ion. What's its charge? It's a -3 charge. Good. Okay. So let's do our crisscross. The 1 goes there, the 3 comes over here. Sodium, what's its symbol? Na. Yes, in this case, I'll need to bring that 3 down below the sodium as a subscript. And what about phosphate now? What's its formula? PO4. Okay, now do I need to bring the 1? No. So that's sodium phosphate. Very good. I should have put an example here where this number was not a 1. Let's say it wasn't, but let's just say this sodium has a +2 charge. Then what would you had to do different here? Can I just bring that 2 down here and put a 2 right there? No, that would be telling people that there's how many oxygens here? 42. And that's just not the case. So if this number is not a 1 and you have to bring it down on a polyatomic ion, what do you need? Parentheses. And we would put the parentheses, the polyatomic ion stays together. So that 2 would come on the outside of the parentheses. Does that make sense? I really should have put an example where that was the case. But anyway, hopefully you'll remember that. Always use parentheses with polyatomic ions. Okay, now let's move into something that's a little more complicated, but I think we'll still remember it from last year. Naming transition metals compounds. Transition metals can have more than 1 charge, so it gets a little more complicated. So they are named by using Roman numerals inside parentheses to represent the charge. For example, copper, it's a transition metal, can have either a +1 or a +2 charge. So its name is either copper 1 or copper 2. Notice, if it's copper 1, it has a +1 charge. If it's copper 2, it's got a +2 charge. Now we're going to use this method with Roman numerals inside the parentheses for transition metals, and also you'll see tin and lead. Tin and lead. So tin is number 50 on the periodic table, and lead is right below it at 82. They also can have multiple oxidation states or charges, so we have to use that notation as well. Okay, last point on this slide, it says, remember, the Roman numeral represents the charge of the transition metal. Fill that in your guided notes. The Roman numeral represents the charge of the transition metal. Okay, so let's go through a few practice problems. This might be the most complicated when it gives us the formula and it wants us to come up with its name. Okay, let's go through. What is Cu, guys? Copper. So I'm just going to write copper. But when you look up copper, can it have more than 1 oxidation or charge? Yeah, it's a transition metal. So I don't know what to put inside the parentheses here. I don't know yet. What is Cl? Chlorine. How do I change its name? Yep, it has to be ending in IDE, so this would be copper something chloride. How do I figure out what goes in there? I've got to figure out its charge, right? Its charge will be what goes in this parentheses. So here's how you do it. What I always do is break this compound into the cation and anion. This is the cation on this side, on the left side, and the anion on the left side. Now the thing about ionic compounds is that their charges always have to balance to 0. So copper's charge has to balance out chlorine's charge to 0. So if we know chlorine's charge, what is it? Yeah, it's a -1. How many chlorines do I have right here, guys? 1. So the total charge on the right side of this compound is a -1, correct? All I'm doing there is taking the charge, timesing it by the subscript, and that's the total charge on that side. Now we can figure out what copper is. It has to be what total on the left side? To balance to 0, it all has to balance to 0. It has to be a +1. How many coppers do I have? 1. So it has to be +1. So how would I show that it's copper with a +1 charge down here? Roman numeral number 1. Okay? So that is copper 1 chloride. Let's go to another one and do it again. Okay? It says, name the following ionic compound with a transition metal. All right, what is Hg, guys?
Mercury.
Hg is mercury. So I'm going to write that over here, mercury. And it is a transition metal, so I know I'm going to have this parentheses with the Roman numeral inside of it. What is O? Oxygen. How do you change its name?
Oxide.
Oxide. Okay, now we're pretty much done, other than we just need to know the charge of this mercury. Again, we can't just look at the periodic table and say, oh, mercury, its atomic number is 80, it's in group 12, so it's got a, we don't know what their charge. So we've got to figure it out from the other side of the compound. What is oxygen's charge? -2. How many oxygens do I have right here? 1. So total on this side? -2. That means total on this side, if it's got to balance, this whole thing's got to balance to 0. What is the number got to be right here? It's got to be a +2. How many mercuries do I have right here? Just 1. So it has to be a +2 charge. How do you write 2 in Roman numerals? Yeah, just 2 lines down. Yep. So that compound would be called mercury 2 oxide, and that's how a chemist would say it, mercury 2 oxide. All right, very good. Let's try one more. Okay, it says name the following ionic compound with a transition metal. Practice problem 15 here. What is Fe? Iron. Yeah, it's one of those that doesn't make sense. I mean, its symbol doesn't really correspond to its name in English, but it would if you knew the root name of iron. Okay, so iron, parentheses, we don't know what its charge is yet. What is O? Oxygen. How do you change its name?
Oxide.
Oxide. Okay, so we pretty much have our answer ready to go, except for the charge of iron. Okay, we don't know it. We can't look it up on the periodic table and say, oh, iron's +2 or whatever. So let's figure it out. Okay. Oxygen's charge? -2. Total oxygens on this side? 1. So what's a -2 times 1? -2. That means this side has to be a total of what? +2, because again, it has to balance to 0. We only have 1 iron here, so what does its charge have to be? +2, because +2 times 1 is +2. So this is iron 2 oxide. Okay, practice problem number 16. So for all transition metals, and remember what I said, for the transition metals and tin and lead, you don't know their charges or their oxidation states, so we have to figure it out. What is Pb, guys? Lead. So I'm going to write it down. Lead. We don't know its charge, so I'm going to use parentheses. What's Cl? Chlorine. How do you change its name? Chloride. Okay, now I just got to figure out the charge of lead. What's the charge of chlorine? A single chlorine anion? It's a -1. How many do I have? 2. So that's a -2 total on the right side. That means on the left side I've got to have what? +2. I have 1 lead atom, so it's got to be what? +2, because +2 times 1 is this +2 times this 1 is +2. So how do I name it? Lead 2 chloride. Very good. Let's try a little bit harder one here. Now we're going to go from the name. It's given us the name, and it wants us to go to the formula. Okay, copper 2 fluoride. Again, if you have the name, guys, what do you write above the name? The charge. What's the charge of copper 2? It's a +2. What's the charge of fluoride? -1. Now what do I do? Crisscross. You bring that 2 over there, the 1 comes over here. So copper, what's its symbol? Cu. What number goes here? 1, I don't need to write it. Okay. Fluoride is what? F. And what number goes here? 2. Can I reduce a 1 and 2? Nope. So that is copper 2 fluorides. Formula. Very good. Number 18. Lead What is this one in Roman numerals? How do you say this? 4. Maybe we should just review. What is this one in Roman numerals? 1. How do you write 2? 2 lines. How do you write 3? 3 lines. How do you write 4? IV. So I always remembered it is that the 1 before. What does 5 mean? Or what does B mean? 5. So it's 1 before 5 is 4. What is that? 5. And then what if it's a line after the 5? That's 6. And then 7, how would you do that? 2 lines. 8? And so forth. I think you won't get more than 8. So IX is 9. Yeah. Yeah, we might as well go to 10, right? IX, and how do you write 10 then? Just an X. Okay. Thank you. All right, so let's solve this one. Lead 4 sulfide. What do I write above lead, guys? Plus 4. What do I write above sulfide? Yeah, sulfide is for sulfur. It's in group 16. It's a -2. Okay. Let's crisscross it. Lead is Pb. What goes here? 2. Sulfide is sulfur. What's the symbol of sulfur? S. And what goes by the S? 4. Now be careful. Can this one be reduced? Yes. What would it reduce to? Yeah, it would go to 1 and 2. So this 2 would become a 1, and the 4 would become a 2. So lead 4 sulfide is PbS2. Very good, guys. Let's try another one. Iron 2 bromide. What do I write above iron? Plus 2. What do I write above bromide? -1. Crisscross it. Iron is what, guys? Fe, yeah. What number goes by the Fe? Just 1, so let's leave it alone. And bromide? Br. And the 2 comes down. Is it reduced? Yes, it is. So FeBr2. Okay, let's do another. Is this the last practice problem? Okay. Practice problem number 20. Manganese. What is this one in Roman numerals again? 4. Bromide. Manganese 4 bromide. What do I write above manganese? Plus 4. What do I write above bromide? -1. We crisscross it. You guys getting the hang of this now? What is the symbol for manganese? Mn. Good job. And 1 goes there. We don't need to write it. Bromide is Br. What number goes by it? 4. Okay, excellent. There's some extra practice if needed. So if you guys need some extra practice, see if you can come up with. Well, should we do a couple of these?
No.
Let's do the odd ones. Okay, we'll do the odd ones. What's the name of this guy? Could I just put copper chloride and circle it and be done? No, you get it wrong. How come? Because copper is a transition metal. You need to tell people its charge. It can be more than one possibility there. So let's put copper parentheses chloride. How could I figure out what the charge of copper is? Chlorine's -1. There's 1 of them, so there's a total of -1. On the right side, it's got to be +1 on the left. So what's the charge of copper in this case? +1. So that's copper 1 chloride. Okay. Let's just do the odds. Let me see if there's. Okay. Number 3. How would you name that? Iron parentheses oxide. Okay. Oxygen's what? -2. There's 1 of them, so it's -2. Iron's got to be what on this side? +2. There's only 1 of them, so it has to be +2. Iron 2 oxide. Okay, and last one. Let's just do this one real quick. What is Mn? Manganese. How would we name it? Oxide. Oxygen's charge, Ruben, is what? -2. You got it. Good job. -2. Times how many do we have here? 2. So that's what charge on this side? -4. Good job. That means this has to be what charge? +4. There's only one of them, so it's got to be plus 4. How do I write 4 in Roman numerals? IV, manganese 4 oxide, and there we go. I should have put an example in like this. What if there was 2 manganese atoms here? And there wasn't, but what if there was? The total on this side has to be plus 4. What would the charge of a single manganese cation be? This would be plus 2. Because if you look here, plus 2 times 2 would give you, a plus 2 times 2 would give you plus 4. So if that was the case, you would just have to change it that way. Okay. That pretty much reviews everything that we learned last year. This is the first thing in this chapter that's new. Okay, we haven't learned this stuff yet. We're going to learn how to name covalent compounds. And it's actually quite a bit easier than naming ionic compounds. Covalent. What does it mean by covalent, guys? Let's quickly go over that. Two nonmetals. So if you have a compound with 2 nonmetals, this is how you're going to name it. Okay? The naming of covalent, nonmetal, and nonmetal compounds is a little different. The rules for naming covalent compounds are as follows. Number 1, the first element in the formula is named first. First one's first, that's obvious. Using the element name. You just use the element name. Rule number 2, the second element is named as if it were an ion and ends with IDE. So again, the second one ends with IDE. Number 3, prefixes are used. What's a prefix, guys? Yeah, prefix is something that comes before the word. So we're going to use prefixes. And they are used to denote the number of atoms present. So prefixes denote the number of atoms present. And rule number 4, the prefix mono is never used for naming the first element. So we don't have to use mono in the first element. For example, CO is called carbon monoxide. It's not called monocarbon monoxide. So if it's the first element in the compound, we never use mono, even though there's one carbon there. We'll go through some examples and it'll make sense. Okay, I've got this in the guided notes. You're supposed to tell me what mono means. How many does mono mean? 1. Okay, what's the prefix for 2? Di. What's the prefix for 3? Tri. So mono, di, tri. Mono, di, tri. 4 is a little bit different. What's the prefix for 4? Tetra. Okay, we're just going to have to remember that. 5. Penta, like a pentagon. So that one's kind of more easily remembered. What do we call a shape with 6 sides? Hexagon. So 6 is hexa would be the prefix. Number 7. Hepta. Hepta. 8. Octa, like an octagon. 9. Nona. And 10. Deca, like a decade is 10 years. So that one's a little bit easier to remember. We're just going to have to learn these and memorize them so that we can name each of these correctly. Okay, pop quiz. What if there's 1 atom? What's the prefix? Mono. What if there's 4? Tetra. What if there's 7? Hepta. What if there's 9? Nona. What about 10? What about 2? Di. What about 3? What about 5? Penta. Okay? And so, yeah, let's go through this. Okay? Practice problem number 21 says, name the following covalent compounds. Okay, first of all, I want you to get used to identifying whether it's ionic or covalent. How come this one is covalent? Because nitrogen is above the staircase and so is oxygen. That means they're both nonmetals. It's covalent. So how would we name this guy? Well, we have to name the first one first. But how many of them do we have? 2. What's the prefix for 2? Di. So we're going to put di. What is it? Nitrogen. So that's called dinitrogen. How many atoms of oxygen do we have right here? Just one. What's the prefix for one? Mono. And what is the element's name? Oxygen, but we need to change it to IDE, so it's monoxide. So how would we name that one all together? Dinitrogen monoxide. Yeah, when it's mono, we don't say the whole word mono out, we just monoxide. Like the one we're most familiar with is carbon monoxide, right? And so we say it like that. Okay, let's go to B. Okay, prefix here. What would it be? How many atoms of nitrogen do I have? One. What's the prefix for one? Mono. But do we ever use mono in the first one?
Nope.
No. So we just do what here? Nitrogen. What's the, how many oxygen atoms do I have? One. So what's the prefix for one? Mono. So it's monoxide. Very good. Nitrogen monoxide. That's how you would say that. Okay, let's go to C. What do you think this one would be, guys? Good. Nitrogen, how many? Yeah, two. Dioxide. That's nitrogen dioxide. Very good. This is easier. This is way easier than ionic ones, right? Let's go to 2. D. That was close. Let's go to D. How many nitrogens do we have? 2. So what's the prefix? Di. Do we use it with the first one?
Yes.
Yeah, the only one that you don't use is mono, right? So we do have to use di. So di-nitrogen. Okay. Good. 3 oxygens here. 3 is tri. Dinitrogen trioxide would be your answer. Okay, take a second, guys, and try E and F. Try E and F on your own. I'll give you a second. Yeah.
Could you get a hold of some sulfur hexafluoride?
I could, yeah.
You should.
You know what it does?
Yeah, it makes your voice go low. It's like the opposite of helium.
Yeah, it's the opposite of helium. It makes your voice go really low. So now you know why it's called that, right? Yeah, good.
Yeah.
What is it, sulfur?
Sulfur hexafluoride.
Hexafluoride. Yeah. Okay, try E and F. I'm going to go over them on the board. You guys see if you got them right. Okay, for E, how many of you guys got dinitrogen tetroxide?
Yep.
Good job. Did we get it?
Yes, sir.
Okay. On F, how many of you guys got dinitrogen pentoxide? Excellent. Okay, some compounds are always referred to by their common name instead of their chemical name, their formal name. We're going to give them a common name. For example, these 3 compounds are always referred to by their common names. Water, H2O. Now, if we were to name that like we just learned, it's a covalent compound. So what would we write here? How would you write it out? How many hydrogens do we have?
Dihydrogen
2. So it's dihydrogen monoxide. Dihydrogen monoxide is the fancy way of saying what? Water. And we're always just going to go by its common name, water. We just know water is H2O. Everybody knows that. Number 2, ammonia, NH3. Again, it's covalent compound. We're not going to go by the formal name here. We're just always going to call it ammonia, NH3. So you got to remember that. Okay, and then number 3, hydrogen peroxide. What would that be called if you were to name it like we just learned? Dihydrogen dioxide. Very good. We are learning something, right? Okay. So always use their common names. That's what this slide is trying to tell you. Okay, now one last thing about naming covalent compounds and naming in general. Let's go over naming acids without oxygen. Okay? If the name of the anion ends in "ide," the acid is named with the prefix hydro and the suffix "ic." Examples. HF, what's its name? Hydrofluoric acid. Number 2, hydrochloric acid. That makes sense. Number 3, what do you think this one's called? Hydrobromic. Very good. Let's write that up. Hydrobromic acid. What about number 4, HI? Hydro what? That's iodine. How do we change its name? Hydroiodic acid. What about number 5? What do you think this one is? Now be careful. This is what, guys? That's cyanide. That's a polyatomic ion. So how do you think we named that one? Hydrocyanic acid. Hydrocyanic acid. Okay, now we're going to name acids with oxygen. It's a little bit different. Okay, if the anion name ends in ATE, the suffix is "ic," IC, is added to the root name. When I was going through school, I always remembered if the anion ended 8, you have to change it to "ic." So here's how I remember it. 8 is like eating something, and it was like icky and like ick. So I always remembered 8, ick. That's just how I kind of associated it, and it helped me remember that. Okay, here's the other case. If the anion has an ite ending, ITE, then the suffix gets changed to OUS. So 8 goes to "ic," and ite goes to us.
How did you remember that one?
You just have to, I don't know. You're just going to have to remember that one. Okay, let's go through some examples and maybe it will make sense. Okay? HNO3. First of all, what is this polyatomic ion called? Let's look it up on our polyatomic ion table. It's called nitrate. So if it ends in 8, what do we change it to? Yeah, it goes to "ic." So we've got to go to "ic." What this acid is called is nitric acid. Nitric acid. Okay? That's how we would name that one. That's just called nitric acid. Okay, let's try number 2. What is NO2 called? Look on your polyatomic ion table.
Nitrite.
NO2 is called nitrite. Okay, it ends in ITE. So if it ends in ITE, what do we change it to? Yeah, OUS. So this is called nitrous acid. That would be called nitrous acid. This acid is one of the most famous, well-known acids there are. What is it called? SO4. What is that? Sulfate. 8. If it ends in 8, what do we change it to? Ic. So it's called sulfuric acid. Okay. Chemists use a lot of that every year. It's probably one of the most produced acids in the world. Okay, let's try another one. H2SO3. SO3 is what? Sulfite. Okay, it ends in ite, so let's come back up here again. Ite, what do we got to change it to? OUS. Would I put the U here? Maybe not. Sulfurous acid. Sulfurous acid is what it would be changed to. And so naming acids is a little bit complicated. Just remember 8 goes to what? Ik. 8 ik. And ite goes to what? OUS. To us. Oh, there's another one. Okay, number 5. PO4, what is this one called, guys? Phosphate. So it ends in ATE. What are we going to change it to?
Phosphate.
What would I change it to, guys?
Phosphate. Phosphate.
I'm sorry. So it's changed to phosphoric.
Phosphoric.
Phosphoric acid. Another well-known acid, phosphoric acid. Okay. I think we're going to pause here for a second. We're going to pause here for a second because you've learned enough to do a worksheet in the student workbook. You can now do naming covalent compounds worksheet. It's in the student workbook. So I'm going to pause the video for a second while we do that. So if you're listening, you can complete that worksheet now.